So it's very common in the sciences that we have weight percents and we want to convert them to mole percents. And there are a couple of reasons for this. One is weight percent values are the easiest thing to measure. So let's say you go into the garage and you have a bucket of fayalite and a bucket of forsterite, and you want to make some kind of intermediate composition. Let's say that is half forsterite plus half fayalites. We'll just write those out. It would be easy to weigh out sort of equal weight proportions. But then what would that look like from a mineral formula perspective? When we talk about mole percents, this is what we write when we're writing a formula. So we're writing atomic or molecular proportions here. This is not the weight proportions. So if we had, 50% of this, so we'll put 0.5 plus 50% of that, what would we have from a mole percent value? So that's what we're going to look at here, because this is really the most common way that we actually report mineral compositions. Even though we prepare them or measure them in weight percents, we usually report them in mole percents. So let's take precisely this example as a case study. So for forsterite, we have a molecular weight of 140.7 grams per mole. So forsterite is this guy right there. So that's forsterite. And then fayalite is this fellow over here, the iron end member, and having iron in place of magnesium, no surprise at all. It is heavier at 203 grams per mole. So when we talk about a mole, we mean on the basis of 4 oxygens, just the way we've written it here. So we have the atomic weight of this guy and the atomic weight of this guy. Well, if we're going to have 50% of each, well, what we could do to get, if these are weights, so if we have 50% by weight of forsterite plus fayalite, so just equal amounts that we've weighed out, what would that be in terms of the atomic proportions? Well, to figure that out, what we would do is take 0.5 for the forsterite case and divide that out by the atomic weight of 140.7. And if we do that, we're going to get a pretty small number, 0.003554 thereabouts. These are zeros here. And if we do that for fayalite, the same kind of calculation, we have 50%, and we're going to divide it by its weight, 203.8 grams per mole, and we get another tiny value, 0.002453 or thereabouts. So we'll take the sum of these two things, these molecular proportions, and we get 0.006007. So if we want the molecular proportion of forsterite, so that molecular proportion would be this value here, 0.00355. We're going to run out of space, so I'm just going to cut a couple of decimals off, and that would be divided by 0.006007. And if you carry all that out, multiply this by 100 if you want to get a percent instead of a fraction, then this will be equal to 59.16%. This is the mole percent of forsterite. And then if we do the same calculation over here, we would take 0.00245 and carry the rest of the decimals, multiply by 100, and divide that out by the sum, 0.06007. We should get 100 minus this, or something close to about 40.9%. So those are the mole percents. And take a look at this. Even though we have 50% by weight of fayalite, or the iron end member, it's only 49% molecularly. And that intuitively should make sense. Iron is heavy, so even if we have a smaller amount of iron, it takes up a greater fraction of the total weight. Now, how would we write this? Well, we usually write it writing the letter FO with subscript, and then we write 59.1, and this would be equivalent to writing fayalite 40.9, because in olivine there are really only two major components. And yes, we could dissolve some nickel or calcium or manganese components, so maybe forsterite and fayalite would not sum to 1. Maybe we'll do another calculation where we show 3 components instead of 2. But here we have 2 different ways that are equivalent of expressing this mixture. So if you went into the garage and measured out 50 grams of forsterite and 50 grams of fayalite, melted them and created a solid solution, that solid solution would have a formula that we would express as FO59.1, meaning that on a molecular basis it is 59.1% forsterite.